In this last example, when we're talking about continuity, this actually goes back to section 1.3, where we covered, maybe it was 1.2 part 2, I think, where we wanted a point to be filled in. So in this case, we want to find the value of k, or constant, if possible, that's going to make this function continuous everywhere. So what we want to do is take a look to see if the limit as x approaches, in this case, 1 from the left, and the limit as x approaches 1 from the right will be equal to each other. And we need to figure out what this k value will be. So what you do is you take the limit as x approaches 1 from the left of 6 minus x squared, and we want to set that equal to the limit as x approaches 1 from the right, which is this one, of x plus k. Now, if I ask you to evaluate the limit of this side, all you have to do is direct substitution. So plugging in 1 gives me 6 minus 1 squared, or 5. In this case, I would still plug in my 1 for x, but I still have a variable. So we're going to say 1 plus k. So now I can solve for k to make this continuous. So k should be equal to 4. Okay, so what we want to do is check before we write our answer. So I'm going to go over here. This is our test. All right, and we're going to look. So we have f of x is equal to 6 minus x squared when x is less than or equal to 1. And we're saying that if if k is equal to 4, this is what this would look like, okay, for any value greater than 1. So let me test. The limit as x approaches 1 from the left, 6 minus x squared, should be equal to the limit as x approaches 1 from the right of x plus 4. When I use direct substitution, these two sides should be equal. So we have 5 is equal to 5, so this works, check. So what we're saying, okay, is that if we replace k with 4, f of x will be continuous. Okay, that's what we're saying.